Greetings everybody. I'm going to take a chance to do this problem, which at least at the time I'm making this video is question 14 from assignment 2.2. If you watch this video in some later semester, it may be a different problem in the assignment, but it will still be part of it somehow. So the question is that we're dealing with a standard 52 card playing deck, and the event and the probability in question is of selecting a red card and then selecting a black card, alright, given that the first card that you take out of the deck is not replaced. Okay, now the way that I want to frame that question is that that's the probability of events occurring in sequence. Okay, so the way we would categorize this problem among all the kinds of problems we'd see is that I want to know the probability that some event A occurs and then after that some other event B occurs. Okay, now we might just write that in simpler terms as the probability of A and B. Alright, so this is the situation we're in. This is what might differentiate this problem from other kinds of problems. Now there's formulas that you use, at least the way I'm going to explain it to you, are that the formula would depend on if the events are dependent or independent events. Okay, so I'll talk real quickly about that. I know I mentioned it in other videos, but it couldn't hurt to remind you since you're watching this one. Dependent events, let's say we can talk about like this. Events A and B are dependent events if the fact that one has already happened changes the probability that the other will happen. Okay, so can you imagine that one thing happening might alter the probability of some other thing happening? So give me an example. What are the odds that you select a black card at random from your standard deck of playing cards, which looks like this? Okay, well, so there are 52 cards in the entire deck, and there's 13 clubs, which are black, and there's 13 spades, which are black, so there's 26 black cards. So the odds of selecting a black card out of the 52 card deck is 26 out of 52. Okay, that reduces to a half if you want the fraction, or the decimal 0.5. Now, I want to give you an example of dependent events. These events would be dependent. Okay, think about it. Suppose I say that you select a red card and you don't put it back in the deck. Does that change the odds of selecting a black card? It does. Why is that? Well, because if you take a red card out of the deck and you don't put it back, there's now fewer cards in the deck. There's only 51 cards instead of 52. So it changes the probability of selecting a black card. If you just select a black card out of the deck as is, the odds are 26 out of 52. But if you first take a red card out and you don't put it back, then the odds of selecting a black card at random are different. Okay, so that makes these events right here dependent. The fact that this one already happened changes the odds that this one will happen. You can't say the odds of selecting a black card are 26 out of 52 anymore. Okay, they're now 26 out of 51. The reason is if you take a red card out of the deck and you don't put it back, there are still going to be 26 black cards left in the deck, but there will only be 51 cards total because you took one of the red cards out. So there's one fewer cards in the deck. So that's an example of dependent events. Okay. Now, independent events is the other case for the formula. These events would be independent if I took the red card out and I put it back. All right, because then it's like the deck is just like it was when you started. Okay, so if the problem was such that says we're going to take a red card out and then we're going to put it back in, then we get independent events. That wouldn't change the odds of selecting a black card. In that case, it'd still be 26 out of 52. All right, so hopefully you have a feel if you had forgotten what they were, what dependent events are. Now, if I'm going to do this problem from our assignment at this point, okay, so which sounds a lot like the example I was just talking about, that we are going to take 2 cards from the deck. The first card that we take out is not put back in, okay, before the second card is selected. So we're dealing with dependent events. All right. Then what's the probability of selecting a red card and then selecting a black card? Okay, so let's write that this way. So I'm going to say probability of selecting black, and when I write this vertical bar here, that's our notation for conditional probability. So we say the probability of selecting a black card given that you've already selected a red card. Okay, oh whoops, sorry, I gotta write out the whole formula. The probability of selecting a black and a red like that, okay, is gonna be the probability of selecting red times the probability of selecting black given that you've already selected the red. That's how we would write the formula. So we'll calculate the probability of selecting a red card as it is out of the deck, then multiply that times the probability of selecting a black card given that you already took a red card out and didn't put it back. Okay, this vertical bar is called conditional probability, the probability that we select a black card on the condition that we already took a red card out. That's what the notation here, when I put this vertical bar there, that was conditional probability, the probability that this thing happens given that this other thing has already happened. All right, so let's do these one at a time. What's the probability of selecting a red card? Well, you look back at that deck of cards I've got mapped out over here. There's 52 cards total in this deck, and there's 13 diamonds, 13 hearts, there's 26 red cards, so that's going to be 26 out of 52. And then times what's the probability of selecting a black card given that you took a red card out of the deck and you didn't put it back. Because remember, that was one of the conditions of the problem, is that the first card is not replaced before taking the second card out. Right? So that would be, well, there are 26 black cards still in the deck, but only 51 cards total, as we talked about. Now, so I multiply those, I'll get my answer, okay? And I'm going to look and see how I'm supposed to put that answer in. It says round to 3 decimal places is needed. So what I'm going to do is I'm just going to do this on my calculator. I'll do the fraction 26 over 52 times the fraction 26 over 51. And I'm going to get a decimal, which according to my math lab, for those instructions, I'm going to round 3 decimal places. I get 0.2549. Okay, so let's write that here on the whiteboard just for the sake of having it down. 2549. And if I'm going to follow those instructions for rounding to 3 decimal places would be rounding to that decimal place where the 4 is. Because this next digit is a 9, that's going to be 0.255. Alright, so let's go back over here. And we got our answer, 0.255. Alright, that's the probability of selecting a red card, leaving it out of the deck, and then pulling a black card out. Okay, so we got it there. Now, this is not the only video I've made on this topic, okay? And this is not the only video I would want you to see to be exposed to this. We'll need to know what dependent events are, what independent events are. When I write that vertical bar, meaning conditional probability, same thing over here, conditional probability and so on. So I've covered that in other videos. If those things aren't so clear, go back and look at the other videos listed for the assignment. But hopefully, like, if that's a given, if you've seen those and you just need something directed at this particular kind of question, then what I have here will cover it for you.